In this video, we're going to talk about how to find the horizontal asymptotes of a rational function. But before we do that, let's look back at vertical asymptotes and wholes as a little review. So the vertical asymptotes are the values that make the denominator equal 0. The wholes are also the values of x that make the denominator equal 0, except these are the factors that would cancel out. So in this equation, there's going to be a vertical asymptote at positive 3 because 3 minus 3 is 0. In this second equation, though, notice that these x plus 2's would cancel out. And so there's going to be a hole in the graph at the value of x that makes this factor equal 0, which would be negative 2. So there will be a hole at negative 2. And then the factor that did not cancel out, there will be a vertical asymptote, in this case at positive 3. So looking at the graphs of these two equations, notice that this one does have a vertical asymptote at positive 3, and so does this one. They both have a vertical asymptote at positive 3. This one also has a hole in the graph at negative 2. So what we're going to look at next is how to figure out where the horizontal asymptotes would be on these graphs. So, horizontal asymptotes. What you need to know about these is that it depends on the degree of the numerator and the degree of the denominator in the equation. And so I'm going to refer to the degrees with n and d. N being the degree of the numerator and d is the degree of the denominator. Remember that degree is the biggest exponent in a standard form polynomial. So we're going to consider three possible scenarios. Either the degree of the numerator is less than the degree of the denominator, or they're equal, they have the same degree, or the degree of the numerator is greater than the degree of the denominator. And each of these three situations is going to have a different horizontal asymptote. So we'll start with n is less than d. And so to do that, we are going to look at this equation first. So with this equation, notice that the degree of the numerator would be a 1. That's x to the first power. And the degree of the denominator is 2. So 1 is less than 2, right? The degree of the numerator is less than the degree of the denominator. And so that graph is going to look like this. If n is less than d, then the graph will have a horizontal asymptote at y equals 0, right there on the x-axis. So anytime you see a rational equation where the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is at y equals 0. Then the next possible scenario is n is equal to d. And so in that case, we are going to look at this equation. So we're looking for the biggest exponent in the numerator and the denominator. And so this is x to the first power. And so is this x to the first power. So they have the same degree in the numerator and the denominator. The degrees are equal. So in that case, the horizontal asymptote is the ratio of the leading coefficients. So the leading coefficient of the numerator was 8, and the leading coefficient of the denominator was 2. And so the horizontal asymptote of this graph is the ratio of 8 over 2, which is 4. That is why this graph has a horizontal asymptote at y equals 4. All right, and then the third possible scenario is that n is greater than d. The degree of the numerator is greater than the degree of the denominator. So here the degree of the numerator is 2, and the degree of the denominator is 1. That's an x to the first power. So n is greater than d in this equation. So when this happens, there is no horizontal asymptote of this graph. There is actually what is called a slant asymptote or a diagonal asymptote, and that's this line right here. So in this video, we're not going to get into how to find the equation of this line. There is a way to do that using polynomial division. But what you need to know for this class is that when the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. So let's look back at these equations that we looked at earlier with the vertical asymptotes and holes. And let's draw in their horizontal asymptotes now that we know where to find them. So in this first equation, we want to look at what is the degree of the numerator and the degree of the denominator. So that's an x to the first power. So the degree of the numerator is 1. And the degree of the denominator is also 1. They both have a degree of 1. And so looking back here at our 3 possible scenarios, the equation we were just looking at, the degree of the numerator and denominator are equal. And so the horizontal asymptote is the ratio of the leading coefficients. All right, so here's our equation we were just looking at. Our leading coefficients are 1 and 1. Those are the coefficients in front of our leading term, or the term with the biggest exponent. And so 1 divided by 1 is 1. So this graph has a horizontal asymptote at y equals 1. So I'm going to draw in this dashed line right here. And then this graph. So again, we need to consider the degree of the numerator and denominator. And we're going to look at the original equation, so before we had canceled things out. And I could rewrite this equation with the denominator multiplied together. So if I multiplied these, I would get x squared minus 1x and minus 6. And the numerator was x plus 2. So the degree of the numerator is 1. That's x to the first power. And the degree of the denominator is 2. Or you could have seen that here there was 1x in the numerator. The degree there is 1. And in this factored form, there are 2 x's, so the degree of the denominator is 2. Okay, so this degree of the numerator is less than the degree of the denominator. So going back here, the degree of the numerator is less than the degree of the denominator, and so the horizontal asymptote will be at y equals 0. And so on this graph, I'm going to draw in the horizontal asymptote at y equals 0, which is right on the x-axis.